this video we are going to go over box and whisker plots. Box and whisker plots are a way of representing data. So these are used to represent data. A lot of computer programs will produce a box and whisker plot for you. So when I put like grades into Aries or something, I can make the software give me a box and whisker plot to kind of give me a big picture. When I worked in advertising, in sales, I would print up box and whisker plots. But unless you know how to make them, you don't know how to interpret them. So this is kind of a practical lesson that goes through like this statistics kind of data stuff. You've probably seen it before, but maybe not, so we're going to go through it here. First, vocabulary. When we're talking about a range, we're talking about kind of the span of data. We're saying like, what's the range between what is the number span, and to get that you do the maximum value minus the minimum value, and that tells you kind of the spread. The lower extreme is the lowest number in your data set. Let me zoom in here. It's also called the minimum or min. The upper extreme is the largest number, and it's also called the max. Median, just like if you're driving, for those of you who are drivers, the median is that piece of cement in between lanes. It's the middle number in a group of data. It's also called quartile 2. So some people use the vocabulary median, some people will call that quartile 2, and I'll talk about quartiles more in a minute. The lower quartile is the middle of the lower half of data. So it's the median of the lower half, quartile 1. The upper quartile is the median of the upper half, quartile 3. And if you kind of picture, well, we'll see it better when we get to an example. The interquartile range is the spread of the middle set of data. So we get that by doing quartile 3 minus quartile 1. So this is like a lot of vocabulary, but it kind of makes more sense when we go through an example. So let's do it. All right, so this is going to take us through the steps. So the first thing that we do is put our data in order from smallest to greatest. So I've got 15, then I see a 17, a 19. So I just kind of go through crossing things out as I go. I've got two 20s. I'm going to write both of them. Let's see, then we've got 23, then 25 and 26. We've got 28, two 28s, 28 and 28. I see 31, 36, 42. And 50. So it's always a good idea to just check that you've got them all. So I'm going to count how many numbers I've got and just make sure I included them all. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in my list. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in my ordered list. So I've got them. So when we're talking about the lower extreme, we're talking about our minimum value. I highlighted that in orange. You can't see it, so maybe it's not helpful anyway. But my lower extreme is going to be 15. And my upper extreme is going to be my maximum value is 50. So I have 15 is my lowest value, my minimum. And 50 is my upper extreme, my maximum. So now we want to find the median. We want to find the middle. So we kind of cross out the ends until there's one left in the middle. If there's two, we average them. Okay, so I'm gonna go not you, 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 not you. So it looks like I've got 2 numbers in the middle, which makes sense because I had 14 numbers. I had an even number of numbers. So my median is going to be the average of those 2 values. Oh, I guess they gave me a list here. So let's see, we said between 25 and 26. So I'm just going to notice that I'll have 1, 2, 3, 4, 5, 6, 7 in the bottom half and 7 in the top half. So my median is the average of 25 and 26. So I'm going to add them up and divide by 2, and I'll get 25.5. That's my median. That's my middle value. And it came from averaging those 2 middle numbers. So now I want to find the lower quartile. So let me put median, which is quartile 2. The lower quartile is the median of the lower half of data. So our lower half of data is the 1, 2, 3, 4, 5, 6, 7 numbers down here. They've listed them below. So I'm going to do the same thing, but only with these values. Not you, not you, not you, not you, not you, not you, you. So 20 is the middle value. Since there was only one middle value, that is my quartile, my lower quartile, which is also called quartile 1 by different books. So you should be familiar with the language. Lower quartile and quartile 1. And that's 20. And notice it was that first 20, so I want you to kind of see why they're called quartiles. So this was our lower quartile or quartile 1. We're going to go through the same process, but for that upper half, so we're still like not you, not you, not you, not you, trying to find the middle of that top half, the higher half. So not you, not you, not you, not you, not you, not you, you. So 31 is the upper quartile, which is also called quartile 3. Upper quartile, quartile 3 is 31. So right there is the middle of that top half. That's called upper quartile or quartile 3. And the reason they're called quartiles is because by finding the middle, then the middle of the bottom, the middle of the top, just worth noticing, we're splitting our data into 1, 2, 3, 4 quarters. So those 3 barriers, those 3 values, break it into 4 sets, hence quartiles. All right, so now on to the back. We're going to actually make our box and whisker plot, and it's a bit annoying here that we have to kind of flip back and forth. So for our own purposes, I'm going to kind of show this while bringing up the other page. That way you can kind of side by side see both. So now we have all of the values we need. We have all of the critical numbers, the min, the max, the median, and the lower quartile and upper quartile. From here, we're going to construct our box and whisker plot. So it says to make a box and whisker plot looking at the range of data, your number line has to contain the least and the largest. So just noticing, I have to go from 15 to 50. So I'm going to make my number line go by, like, I don't know, 5s should be okay. So if I started, I don't have to start at 0. So for funsies, I'm going to show you starting at 10. But I do need to make evenly spaced intervals. So 10, 15, 20, 25, 30, 35, 40, 45, and 50. All right, so I had, and I could keep going, 55, right? I have a number line. Notice I'm not just putting my critical values, I'm creating an evenly spaced number line. So that was part A. We set up a number line. We could go by 1s or 2s or 5s or 10s. And we're going to plot our lower and our upper extreme, and we're going to do that with a dot above it. So our lower extreme was 15, our minimum was 15, and our upper extreme was 50. So I'm going to put a dot at 15, and I'm going to put a dot at 50. Now we need to plot our median, our lower quartile, and our upper quartile, and I'm going to, so these were with dots, we're going to do these with some lines. So let's see, my median was 25.5, so pretty much right there. My quartile 1, my lower quartile was 20, and my upper quartile was 31. So that gives me the box of the box and whisker plot. Done, done, done. Yep, we did that. We drew our box. Now we draw the whiskers. So now we're going to draw the whiskers that connect the box to the upper extreme and connect the box to the lower extreme. So usually a computer program will produce this image for you, but you have to understand how the image was created so you can interpret it. So if all of those values represented scores on a test or something, and kids got between 15 points and 50 points, this tells me that most kids got between 20 and 30, right? That most of the data, in fact, half of the data, falls within this box. This also shows me that I've got some outliers here. There are, like, this extreme is really spread out. More students are in the lower end than in that higher end, but there's like a variation here. So 75% of all of the data is in this bottom 1, 2, 3 fourths. And then that other 25% of the data is really spread out along the top. So maybe I've got some outliers here that are throwing off the data. So there's kind of a lot of interpretation that you can get from a box and whisker plot, which is why they're a thing. All right, so we've gone through the process of making a box and whisker plot. You are going to practice a few box and whisker plots of your own. Don't forget to put the numbers in order. And yeah.